Hi and Assalamualaikum. My name is Wan Muzaffar Amin bin Rusnawi. My metric number is AA20098. So, we will proceed with the introduction of permanent magnet DC motor project. So, the electric motors basically produce motion from electric power. So, motors are critical to a host activities ranging from manufacturing to transportation and even toys. So, the permanent magnet DC motor is an advanced type of the similar to induction motors. It is also known as direct current motors. It is rely on DC power to operate and are employed as both motors and generators. So it utilizes the power of electromagnetic principle to generate torque. So as the name indicates, this motor uses a permanent magnet to create the magnetic field for operating the DC motor. So DC motors are widely favored as actuators in electromechanical systems due to their simplicity and cost effectiveness, providing a practical means of generating motion or forces. In this project, there are three main objectives, which is first, to understand the working principle of the permanent magnet DC motor. Second, to design and build a permanent magnet DC motor. And third, to test the permanent magnet DC motor based on electromagnetic action. So that's all from me. Thank you.
Hello, my name is Sharvika. I'll be continuing for the literature review where it is mainly about how does a DC motor work. The working principle of a permanent magnet DC, which is PMDC motor, is based on the interaction between the magnetic fields of the stator and the rotor. When a current flows through the armature windings, a magnetic field is created around the windings, so that this magnetic field interacts with the magnetic field of the permanent magnets in the stator, generating a torque that causes the rotor to rotate. And the permanent magnet mounted on the stator create a fixed magnetic field, and the armature windings, which are wound around the rotor, carry the electric current supplied by an external power source. As the current flows through the armature windings, the magnetic field is generated around them. The magnetic field of the armature winding interacts with the magnetic field of the permanent magnets, resulting in a torque that causes the rotor. So, in conclusion, the working principle of a permanent DC, which is PMDC motor, is based on the interaction between the mainly between the magnetic fields of the stator's permanent magnets and the rotor's armature windings. This interaction generates a torque that drives the rotation of the rotor, allowing the PMDC motor to perform various mechanical tasks. Okay, that's all from me. Thank you.
Okay, good afternoon everyone. My name is Vishnu Magendran, and so for today we'll be moving on with methodology now. So from methodology we can see these are the materials that were used. Example were such as shown as a tape, battery, magnet, copper wire coils, paper clips and a blade. As for the measuring equipments we had to use, which were vital for obtaining results in this project, we had a tachometer. So what the tachometer does is, the tachometer will read the rotations per minute or revolutions per minute made by the copper coil in our circuit, thus giving us a more accurate reading. And the multimeter was just used to measure the current that was produced throughout the entire circuit. So over here we can see our preliminary sketch, or our primary main first sketch of our concept. So what we have here is just a simple drawing of how the magnetic field will affect the coil when it is placed on top of a battery. And here we can see our final circuit decked out, looking decently okay, with the magnet situated right above the battery and the coil situated right above both of it. The following videos that are going to be shown will demonstrate the working principle of 10 coils and 20 coils.
A very good afternoon. My name is Taranjit Singh, Analaki Bhajan Singh, metric number DD20283. Now I'm going to proceed with the result and discussion. The table shows the result and analysis for the DC motor result that was constructed. The current value is taken by using a multimeter in the unit of milliampere, and RPM value is taken by using tachometer. The value of the current is taken 3 times to improve the accuracy of the result, as you can see in the table. Based on the tabulated result, the voltage source of the AA battery is kept constant, which is at 1.5 volt. From the table also, it can be observed that as the number of windings of the copper coil increases, the current and the rotational speed in RPM of the DC motor that was measured also decreases. Next, moving on to the construction of the graph. In this experiment, we construct two variables of graph, which is current versus the number of turns, and also current versus the rotational speed RPM. So moving on to the first graph, which is current versus the number of turns. From the graph for the current versus the number of turns shows that there is a linear trend decrement. As the number of turns of the copper coils increases, the current generated by the DC motor during revolution also decreases. This means that when the number of windings of the copper coil increases, the output current measured by the multimeter also decreases. Why? When the number of coils in the armature increases, each individual coil carries a smaller portion of the total current. This is due to the distribution of the motor total current through its coil. The current flowing across each of the coil becomes less. The greater the number of windings in the coil, this will increase the resistance. According to Ohm's law, V equals to IR, but in this case we kept the voltage constant, which is at 1.5 volt. So by increasing the number of windings, the resistance increases, causing the output current drops. So moving on to the second graph analysis, which is the revolution per minute versus the number of turns of coils. The graph of rotational speed RPM versus the number of turns shows that there is a linear trend decrement also. As the number of turns in the copper coils increases, the rotational speed RPM generated by the DC motor also decreases. Increasing the current in the number of turn winding increases the resistance of the DC current. The low current affects the rotational speed of the coil that causes it to produce a low RPM. In DC motor concept, the rotational speed of the motor depends on the voltage and the torque load. The torque of the motor increases along with the armature coil number of turns. A lower speed results from the motor's ability to overcome greater loads or resistance as its torque grows. On the other hand, increasing the speed of the motor while decreasing the number of rotations can result in a drop in the torque output, but at the same time increasing the speed of the rotor RPM.
My name is Waina Masara. So, as a conclusion, it can be inferred that the magnet established an external magnetic field that facilitates the rotation of the coil. The presence of the magnet allows the current to reverse direction through the coil every half turn, ensuring that the coil maintains its rotational motion in the same direction. The flow of current from the battery to the pin and through the copper wire demonstrate the practical application of electromagnetic induction.